All right, so questions at this point. Did PA1 make sense in the end after all the debugging and figuring out weird bash syntax and stuff like that? You feeling fairly reasonable about bash scripting? And that's really all there is to bash scripting. There's other statements, there's for loops, there's case statements, there's things like that. And we'll talk about more ways we can embellish scripting in bash, more nuances we can have with variables, with taking command line arguments and so on and so forth, functions. But I mean, it's kind of a synonym for C programming. Right, stuff in C, stuff in bash. They're just different syntaxes and such. But if you can come up with an algorithm, right, you can code it in bash. The nice things about bash are that it's like quicker usually to develop than C, right? Because you don't have to compile and such. You don't have to initialize variables, allocate memory, all of that. You can easily run any command in Linux by just using the name of the command in the script. So if you want to sort a file, you can just say sort file, right, and do whatever with it.
Why don't we have to compile it?
Because bash is an interpreted language. So there's sort of two categories of programming languages: compiled languages and interpreted languages. Compiled languages basically get changed into the binary code that actually runs on the CPU. So your C program goes through a series of transformations and eventually becomes a bunch of ones and zeros. Those get thrown into memory by the operating system, and it says, go to this spot in memory, start executing those instructions. So that's a pure compiled language. An interpreted language is something like bash or MATLAB, where there's a program running. It's actually a program called bash that opens your file, reads the first line up to the new line, and then parses it. Says, oh, this is ECHO, that's the echo statement. I'm supposed to take whatever comes after here and display it. And here's a $sign, so let me see if I know the value of that variable, and if I do, I'll replace it. And it does this one step at a time. Don't have to compile it. It's a little slower because you've got this program running, and bash itself was a compiled program. So that's the ones and zeros the CPU is actually executing. It gets interesting with things like Java, which is compiled but also interpreted. It gets compiled, but not to the ones and zeros that the CPU understands. It gets compiled to something called bytecode. And there's a virtual machine called the Java Virtual Machine, JVM, that interprets those ones and zeros. And the JVM itself is a compiled program. So you've got sort of the bare bones metal level, and on top of that is this virtual machine, and then that's interpreting the ones and zeros, which you got by compiling the Java code. So it gets all kinds of interesting. It gets even more interesting because sometimes the actual ones and zeros, Engineering 270, right, you take an increment file register instruction, you change it to 11010, right? That's what I mean by the ones and zeros, the binary code that sits in the memory. Sometimes on some machines that's not actually executed, it's interpreted, because there's a little hardware machine inside the CPU which is reading these ones and zeros and saying, oh, 1001, that's an increment. Okay, let's see what I should increment. And there's a micro machine inside the CPU. And so your binary machine code might actually be interpreted. So it's a wiggly, slippery area. The lines aren't rigid. That was way beyond what you asked, but I like talking about that stuff. So yeah, bash is fun, and I actually make use of it all the time. Like when I want to grade your programming assignment, right, I have a script called git clone. I can show you git clone actually. Right, so I just run this script, and all I have to do is say git clone space PA1. Okay, and it will zero out a file called git clone errors. It'll make sure I gave it a project name, so it'll make sure my argument $1 is not empty. And then basically I read a file called get IDs, and this is just a flat file I made. It has your username according to Canvas, right? Last name underscore first name, then has your get ID. And I made this from your homework 1 submissions. And so this while loop basically reads each line of the file one at a time. Set is a program we'll talk about towards the end of the quarter that basically breaks a line up into pieces. So it breaks it out into your user ID and your get ID. I make sure you've got a directory in my subdirectory called users with your username, which you do at this point. It makes sure you have a get ID. If not, I print an error message saying there's no get ID because you didn't do homework 1. Well, everybody's done homework 1, so I have all your get IDs. So then I CD into that directory. Okay, this is your directory. And I do a git clone statement, right, which basically pulls off, goes to GitLab with your get ID and tries to read whatever the project was I specified, PA1. $? We haven't talked about, but we will. That tells you the result of the previous command. If it's 0, the previous command succeeded. So if that's 0, success. Otherwise, I'll print an error message saying I can't read that project for that user, and I'll put that into my error file. And that's just a big while loop. So one command, git clone space PA1, enter, and I walk away and come back a few minutes later, and all of your projects are downloaded into their own subdirectories underneath your Canvas username. And then I can tar that up, put it over to a test account, untar it, and go ahead and test your stick programs. So if I didn't have that, right, it would take me, half hour or so to do all of those downloads, probably more. I'd have to look up each of your get IDs and so on. And this just kind of like automates it. So that's the kind of thing that you end up doing with scripting if you're working in a Unix environment. And I've got tons of scripts that I use. I use scripts for making the attendance sheets that I pass out. I've got scripts for seeing how many people have done the latest ODP, seeing how many people have not gotten a perfect score on the latest ODP. And the sky's the limit. All right, so any other questions, comments up to here? Yeah.
A comment block versus a README, should we have both versus?
For this assignment, if I want a README, I'll definitely say include a README, and I generally won't. It's kind of good practice to make READMEs for Git, just so that when you go to the repository, you sort of see the README right there on the bottom. But I'm not requiring it. Other people might down the road. I tend to write a lot of READMEs in my own directories, and they become, README, README1, README really important, README.real, stuff like that. And I never read them. And then I have to-dos and importance. All right, so let's look at PA2. So we're just going to keep going with a stick game, right? Better than Fortnite. So PA2 is the same basic game as PA1, except there's a few significant changes. So number one, this is written in C. Okay? So PA1 was a bash script. PA2, same behavior of the game basically, but it's a C program. And the following changes. First of all, the user always goes first. So you don't ask user or computer who wants to go first. User goes first. Okay? The user might behave very badly when they're typing in input. They might type numbers that are legal. They might type illegal numbers. They might type, asterisk, $, question mark. They could type in anything. They might hit nothing at all. They might just hit the enter key. And you need to handle all of these situations. Okay? So the user might behave badly, might enter anything at any time. Determining how many sticks to play with, you have two options. Did I tell you what to call this? Okay, so call your executable program stick. So there's two ways that you can use the program stick. One is you can say stick 30. And that says, I want to play with 30 sticks. And if the person says name of the program space 30, you just play the game with 30 sticks. Okay? You don't have to ask how many sticks. You've said 30 sticks, is that correct? Nothing like that. Stick 30, enter, just start playing. Show the pile of 30 sticks, the user gets to go first. Okay. The other option is the person might just say stick without specifying a number. And in that case, we're back to the case that we were in with PA1. Ask the user, how many sticks do you want to play with? Okay, so if you don't want to have to answer that question separately, you can run your program just saying stick space number of sticks. If you just say stick enter, then it says how many sticks do you want to play with. Okay, so they can have exactly one argument, which is a valid integer, which is a number bigger than or equal to 10. Or they can have no argument, in which case you ask them how many sticks they want to play with. Alright, if there's any errors in the number of sticks, print an error message and exit. Don't have to give them a second chance. If they say stick ha ha ha, you can say that's not a valid number of sticks, goodbye. If they say stick -5, that's not a valid number of sticks, goodbye. If they say stick enter, how many sticks would you like to play with? And they say -10, not a valid number of sticks, goodbye. Okay, so they get one chance to specify sticks, either on the command line or after they say stick enter and it asks how many sticks you want. Okay, so this is very different from PA1 as far as the error handling. All right, when they're trying to decide how many sticks to take, right? They put in a number between 1 and 3. That one you keep trying, and you keep trying until they make a valid entry. You don't give up after 2 tries. So how many sticks would you like to take? If they put in a negative number, if they put in something bigger than 3 or less than 1, if they just hit enter with nothing, if they say ha ha, if they put in anything other than a valid integer, just say, you know, put in a number between 1, 2, and 3, please, and try again. Keep trying again. I'm going to clarify something else in here. So at least 10 sticks to begin with. All right. Any questions on this, since I'm editing it and adding more wordage to it? So to submit it, same thing as PA1, push it to a repo named uppercase PA2, grant me reporter access by 8 a.m. on the due date, which is 2 weeks from today. Alright, so we'll have some ODP starting next week that, like with PA1, we'll start working with different pieces of this. Parsing command line arguments, which we already started to do with ODP 408, and then prompting for input and processing input and so on and so forth. So we'll build up to that, but that's the basic setup, and you probably know enough C just from 121 to work on parts of this, maybe not the command line processing and so on, but this is an opportunity to really work with modular development, okay, with developing your code in pieces and putting those pieces together. So one piece you can develop is the basic gameplay, right? Just assume we're playing with 30 sticks, right? So set the number of sticks to 30 and just make yourself a big loop that basically says how many sticks do you want to take, subtracts that from 30 or whatever the pile of sticks this variable is, prints out the number of sticks left, and then the computer makes a move, same as PA1. Take the number of sticks mod 4, that's how many sticks the computer takes. Unless that's 0, in that case, take 1 stick. So print out how many sticks the user's taking, that's a printf statement, subtract that from the pile of sticks, print out how many sticks are left. And just make that basic loop. Forget about error checking, forget about when the game is over, forget about how many sticks to play with. Simplify the problem, right? And just build that one internal loop that basically just keeps letting the user make a move, the computer make a move, right? And then start adding to that. Make the pretty picture for the pile of sticks, right? So make a separate loop that prints out a picture of the sticks. And you can bundle that into a function if you like. All right, print sticks, parentheses, n, and that's a function that just prints out n pipes followed by n in parentheses. And now instead of just printing n, call print sticks, parentheses, n. And then start throwing in some error checking. Well, how do you error check? Well, you can make a function called, get user choice that returns an integer. And that function can do the following. Print out how many sticks would you like to take, read a number from the user, make sure it's a valid number. If it's not, go back and try again. Do all of that in a function that you call, and it just returns a valid integer from 1 to 3. And now instead of just doing a scanf in your test program, you just replace that with a call. So if you develop things in pieces, right, it does a few things. One, it gives you progress right away, which is nice. 2, it lets you isolate bugs. Because if you develop this piece and you test it and you're convinced it works, and you develop that piece and you test it and it works, and you put those together in some new piece of code and there's a bug, the bug is probably not in one of those original 2 pieces that you already tested. It's in the way that you're using them in this new section of code. And if that section of code works, right, and then you put that into some other section, if there's a bug, it's in that new section. So it helps you isolate your bugs as you're building up your code. All right, any questions about this?
Should we still be using Nano or Vim to edit, or can we use an IDE?
I would say do not use an IDE. And I'm not taking off points if you do, but you want to type in number sign include angle bracket stdio.h 5,000 times, right? You may not think you do, but you do, because when you get to a test or an interview or something and you have to write a C program, you don't have to remember what the include statement is because you've typed it, millions of times. Or integer main, parentheses, and argc, comma, car, star, argb, things like that. And IDEs just make it a little too easy to write code, which is why we use them, right? And this is another disconnect between academia and workplace, right? If you're on the job and there's an IDE available, you really want to use it, right? But it means you don't have to really learn the syntax very well. You don't have to be very careful with like variable naming and stuff like that, because it'll help you. You type the name of a variable and it'll highlight everywhere that variable appears, right? Well, that's great for writing code efficiently, but it kind of undermines a little bit of your own internal mechanisms for developing code. So I'm going to say don't use it. I'm not going to take off points if you do. And if you've been programming, your whole life and this is second nature to you and you just want to use an IDE to get it over with, okay. But yeah, explore. Any other questions? All right, so we got stuff I want to talk about. I want to talk a little more about Git commands, some Linux shortcuts, some Linux commands, some VI shortcuts, and and working our way back to talking about C. Let me talk a little more about Git, because I've been kind of giving you a really sort of narrow path through the space of Git operations, which was basically, one time making a GitLab account, setting up the SSH key, okay, and then per project one time git init and git remote add origin, and then anytime you have a change you want to push in git add, git commit, git push. Okay, so that's a really narrow set of commands, and that works for most of what we need to do, unless something goes wrong. And when things go wrong, all kinds of weird stuff happens. So let's play with this. So let's make a test directory. Git init. Alright, so I got some files in here. So I did a git init. I'm going to pretend that I'm pushing this off to GitLab. So I'm going to say git remote add origin git at gitlab.com Nick Macias / what should we call this? Let's call it Friday. Okay, so I'm going to say git add star, git commit, initial check-in of junk code, and then git push origin master. Alright, so I have a thing over at GitLab now called Friday, and I've got my code here. Okay, and I'm on the Linux machine, right, with a bunch of other people. So I'm going to log out of Linux, and now I'm sitting on my laptop, right? And let's say I want to work on my project that I've been working on the Linux server. Let's say I want to work on that here on my own laptop because I'm going to the beach and I won't have internet access, right? So I can do something like this: git clone, git at GitLab. I'm working without a safety net right now, so let's see if this works. Git clone, git at gitlab.com Nick Macias / Friday.git. Okay, what just happened? It created a directory called Friday with my project in it. So I just took that repo that I had pushed over to GitLab and I just pulled it down to my laptop, right? I created it on the Linux server, pushed it to GitLab, now it's on my laptop. And I can do a bunch of meaningful work here. So I edited my README and I added a file 4, and I can say git add star, git commit, did some work at the beach, and git push origin master. And those changes are up at GitLab now. I come back from the beach, I have Linux access, I log into the server. I forget where I was doing that. Thank you. All right, so my file 4 is not here. My README is out of date, right? But my changes are at GitLab. I want to update those here. So now we go the other direction. Git pull origin master. And it tells me it pulled 2 file changes, 21 insertions, 1 deletion. And if I look here, there's my file 4, and there's my README file, right? And now my Linux repo is in sync with my laptop repo, which is in sync with my GitLab repo, right? I got 3 copies of this repository now. The main copy is always at gitlab.com. But I've cloned that onto my laptop and I just updated my version on the Linux server. Now I could choose to work on the Linux server, I could choose to work on my laptop, right? Make more changes, push them over to GitLab, and I can always synchronize. Yeah?
Is there a way to automate that, or do you have to do it manually every time?
Automate which part? So yes, but with caution, right? So for example, I could set up something in my login script, my bash RC, so that every time I log onto the Linux server, it goes to this account and it does a git pull. Okay? That may not be something I necessarily always want to do, though. And you can get into trouble with this. For example, let's do this. Let's edit my README. And let's come back here and let's make a different change to my README. Alright, so I've updated my README on my laptop. I also had updates on my Linux machine, but I didn't push those over to GitLab yet. So GitLab has a clone of my laptop at this point. Now if I go to my Linux machine into test, and I say give me the latest copy from GitLab, it's going to complain. Because I've got changes in this local repository on the Linux server that don't match what's in GitLab. And it knows that if it pulls my files over from GitLab, I'm going to overwrite some changes I made to README. Okay, so I've got a conflict. And the only real way to clean this up is to do this yourself. Well, you can ask GitLab to do it, but it's tricky whether it's going to do it right or not. So if you're doing this, right, you want to make sure that you're being really good about keeping GitLab in sync with your changes. If you're only working on one machine, you can make changes for 2 weeks and not push it to GitLab. That's fine. When you're ready to push it, you push it over, not a problem. But if you start working between different systems, if you make changes here and changes here, and they're not in sync with GitLab, right, then it's got a problem, because it's got to try to reconcile those two sets of changes, and it may not be able to do that. So if something like this happens, right, you've got a few choices. If I don't care about my local changes at all, right, if I'm convinced that GitLab has the code that I actually want, and I don't really care about these changes that I made because I was just being goofy, here's what I would do. Move your test directory out of the way. Right, so all of that stuff is still there if I decide I really want it, but right now I've gotten rid of my test directory. And then just clone from the repository into a fresh account. Right, I didn't have to move test because my repository is called Friday, but if it was called Friday, I would move Friday into another area to basically get rid of Friday from the server, and then I would just download a new repo. And then if I go in there, everything is fine. And if I really wanted to be called test, then I would move that into a directory called test. And now I've got my directory test, and it's got all my files from GitLab. And if I try to git pull, it'll tell me everything's up to date. So it's kind of easy to get into trouble, especially if you're still developing the habits of, you know, pushing things over and adding and committing and so on. But it's pretty easy to get out of trouble also. You can always start from scratch. Just save your stuff before you start moving things out of the way and rebuilding Git. Yeah.
So a question about like renaming files and stuff. So,
Yeah.
With PA1, initially I had my executable just called PA1.
Mm-hmm.
And I later renamed it to stick and pushed it over to GitLab.
Okay.
But it created like a second file in GitLab.
Yeah.
And like merged the changes.
Right. So I've got file 4. It should have been file 3. Okay, you can say git move file 4 file 3. and that tells it in the repository to rename file 4 to file 3, and it also renames it here. And then if I say git add file 3, git commit, git push origin master. Alright, that should all be up to date now. So if I'm back here and I say git pull origin master, my file 4 got renamed to a file 3. And same thing with removing a file, you can say git rm file name to remove it. Thanks for asking that, because I meant to talk about that and I would have forgotten it. Alright, so hopefully Git is getting friendlier for you and is less of an issue to deal with and more of just something you do. But we'll use it the rest of the quarter, so lots of practice. Alright, let's talk about some Linux. So in no particular order, let's talk about things we can do in Linux. Did we talk about the prompt? This 5001 in curly bracket business? So we know what variables are in Bash, right? Variable equals value gives us a value. We can say echo $ variable name and see the value of it. So there's a variable called PS1. And PS1 is your prompt. It's the thing that Bash will print before it waits for you to type in a command. And my prompt is set to something a little weird. It's a curly bracket, \, curly bracket. But if I say something like PS1 equals yo, right, that's my prompt now. And every time that it wants me to type something, it will print out my prompt. I type something and hit enter, it executes the command, and then it prints the prompt again. Right, so your default prompt is something like your username @ localhost : and then your directory. And tilde is a shortcut for your home directory. So if I change my directory to 224, my prompt changes to Goblin King @ localhost : ~/224, and then a $. $sign is sort of the classic Linux prompt, but this is embellished. It's got other information in the beginning. And if I wanted a different prompt, right, I can edit my bashrc file. Remember, that's the file that gets executed every time that you start a bash session. And this is where the prompt is being set right now, right? So if I'm using an X term, which I think is what this defaults to, then my prompt is this big long thing. Well, there's all kinds of shortcuts and symbols in here, like \u is your username, @\h is your host name, and so on and so forth. If I want a simple prompt, I can just at the end of my bashrc change the value of PS1 to be just a $sign followed by a space. And now the next time that I log in, there's my prompt. So you can make different prompts depending on what machine you're on, if you like. Or you can just stylize it however you like. And it's just another way to customize. If you see a prompt of a $ sign, usually that means you've got root access. So if you happen to stumble across that, that's like bonus time. Usually $sign is just plain old user access, and the $sign is root. But if you set your prompt to $sign, that doesn't give you root access. Right, so if I become root, I change my prompt to a $sign in curly brackets. And I use the curly brackets to let me know if I'm on the Linux server or my home laptop, because I get them mixed up sometimes, and that's really bad. All right, so So anyway, you can set your prompt. And I'll set it back to this. So you can type history and see the history of commands you've gotten. And if you want to redo some command from the past, you have a few ways to do that. You can do an exclamation mark followed by the number of the command. So I could exclamation mark 5004 to redo my SSH. A more dangerous but easier option is to say exclamation mark followed by one or more characters, and this will recall the last character that started with whatever you type. So if I say exclamation mark SSH, that will recall the last command that started with SSH, which will be this login to Goblin King. If I just say exclamation mark S, it's going to recall the last command that started with an S, which was not SSH. It was this source command, 5007. Oh, well, it's the SSH because I just did that up here. So, you know, if you say exclamation mark R, that's usually really dangerous to do, because you may have been in a directory where you decided to remove all your files and said rm-rf star. And now you're in your home directory. If you say exclamation mark R, it's going to recall that command and execute it, and your files are gone. But it's an option, right? So you can do that. All right, so we'll do something safe like this. Is fun. So a pretty safe option is exclamation mark. That recalls the last command you did. It's kind of like hitting an up arrow. So this just repeats the last command. Let's see if I can find a good. Let's see. Okay, so I've got something called test file. So exclamation mark brings back the last command. Suppose I want to do an ls-l on test file, right? Because I want to see what it looks like in the directory. You can always say exclamation mark $, and that brings back the last word of the previous command. So the previous command was vi test file, exclamation $, means test file. So if I do ls-l exclamation $, that will bring back the word test file. This will do an ls-l on test file. And then if I want to edit that, I could just say vi $, and that'll open the editor. That's not one of those things that's going to, you know, double your effective lifespan because it saves you so much time. But it's really easy to do, and if you get used to it, you find yourself doing this a lot, because the nature of Unix is such that most commands, the output file is the last command. If there's only one file involved, it's usually the last part of the command, and so vi this and gcc this and ls this and change mode this, and it's always the same this, right? And you just keep grabbing it with exclamation $. And sometimes it's easier to just up arrow, or to say exclamation G to repeat the last gcc. But, you know, it's just another tool to have. Exclamation mark asterisk recalls everything except the first word of your previous command. So, let's make a really annoying file. That does nothing. So I want to GCC this. Well, I'm just do exclamation mark, right? So I can GCC it, and then if I want to run it, I can't do exclamation $, because I need to run the thing without a .c. But you know, I might up arrow and backspace and then Control A to get to the start, and then do that. So I compiled it, but I forgot to say -o, right? So I can say gcc -o. Okay, so really long file name that I hate to type. So anytime that you're typing a file name, you can type in the first few characters of it, and if that's enough to uniquely identify a file, you can just hit the tab button and it will fill in the rest. And I don't really want my output to be .c, but I just do a few backspaces. And then I can say long file name, just type the first few letters. Okay, and that one will save you a lot of time. So anytime that you have a name of a file, whether it's a command or something you're editing or GCCing, type in enough to make it unique, and it will fill in the rest for you just by hitting a tab. And now I want to run it, I just type the long file name that I type, and it knows that I have to be typing in an executable file, so it doesn't even show me the .c, and so that runs my program. And if you have, so I want to run a program from bin that starts with a B, and if I hit a tab, it doesn't show me anything. If I hit tab again, it shows me all the possible commands that I could be talking about. So if the characters you type in aren't enough to uniquely pick out one file, hitting tab twice will show you all the possibilities. So yeah, I wanted to do BZ something. Hit tab twice. There's the ones that start with BZ. So BZ diff, if I hit the D, hit the tab, it'll finish up BZ diff. So if I'm sitting here at the prompt and I just hit the tab twice, it says display all 1,546 possibilities, because I haven't typed in anything. By hitting a tab, any file that I might be talking about is potentially what I intended to type. And there's 1,500 possibilities. So if I say yes, it shows me a list of all the things I might have been getting ready to type. These are basically all the commands that it would know about at this point, including cool commands like colon and exclamation mark and so on. Bracket bracket is a command. And so lots of possibilities. All right, so tab completion will definitely save you time. We talked about up arrowing and moving backwards. Control A takes you to the beginning of a line. Control E takes you to the end. Control arrow moves you word by word, where a word is roughly things separated by spaces, but I think sometimes by other things. But you can move around like that instead of having to arrow back a bunch of individual spaces. So those are useful. And I don't think, yeah, go ahead.
What's the equivalent to like Control F to find something? Like a keyword or something if you're looking at a big file and you're trying to jump to a specific.
Like inside a file?
Yeah.
Ah, okay, so we have to talk about VI. But if you're inside VI and you want to find something, just type a slash and then what you want to find. So if I want to find where PS1 is contained, it's right there. And if I hit an N, it'll look for the next occurrence and the next occurrence. And each time I do an N, it'll take me to the next one. Well, that wasn't very exciting because it was at the top. So let's look for school. Nope, it's not found. So let's look for Git. So there's where I have Git. And there's a lot more we can do. We can put in patterns to look for things with wildcards and such, but inside there. Now, if you have a file, you can also use the grep command. So grep, thing you're looking for, and then the name of the file. And that'll show you every line in the file that has that thing in its name. So grep git searches .bashrc for any line containing the word git. Or anything where I mention PS1. And we'll spend about a week playing with Git later, because that gets us into what are called regular expressions, which are really powerful pattern matching tools that we can use not just to look for patterns, but actually to modify things inside a file. We can say find something that starts with 3 letters followed by one of these characters followed by any number of spaces, and replace that second character with the third character, and then repeat the first character 2 times. And we can cobble together something that we type in on our VI command line, and it will do that for us. And that's another one of those things that, like, once you have that in your toolbox, you can't live without it. You're living fine without it right now. But once you've got it, it's like it's indispensable. And that's also kind of the nature of the beast here. All right. I could go on like this for hours. We'll have to continue on Monday. But I want to talk about more ways to customize your environment, how to set up PuTTY so that you don't have to live with things you don't like. Color coding on the display, font size, all of that sort of stuff. And I want to talk about options for running Linux. I don't think I've talked about Cygwin here yet. I've talked to individuals about it, but I want to talk about Cygwin, which is a way you can do Linux from a Windows machine without having to dual boot, without having to shut down and restart. It's a really nice environment for doing code compilation and playing with Linux commands and all that sort of stuff inside Windows. So we'll talk about that on Monday too. We'll talk about VI on Monday for sure, so I'll do a full-on VI tutorial with a handful of commands to add to your toolkit, and then we'll start talking about C and dealing with scanf and parsing and arguments and stuff like that. All right, have a good weekend, and I will see you on Monday or at 12:30.